So in this video, I'm going to do some examples of solving rational equations. I'm going to start very simple and then I'm going to increase the complexity as we go on. So let's start with this problem. It says give me 1 second. There you go. It says 1/4 plus 1/5 equals 1 over t. Now, we need to be careful with the values that are not part of the solution set. Okay, that's very important because some numbers will not be solution for this equation. And what are those numbers, right? Well, usually when you have a rational equation, you do not want to have a number that will divide by 0. Okay, in this case, look at this equation and let's look at 1 over t. 1 over t has a variable in the denominator. Therefore, we have to exclude those numbers that will give you 0 in the denominator. And in this case, it's pretty simple. 0 will give you 0 in the denominator. Therefore, t cannot be equal to 0. It can be any other number, it just cannot be equal to 0. Now, let's simplify the left side. The left side are just two fractions. Whenever you add two fractions, we need a common denominator. In this case, 4 times 5 is 20. So on the left fraction, I'm going to multiply by 5 over 5. On the right fraction, I'm going to multiply by 4 over 4. And then I'm going to leave the 1 over t by itself. So how do we multiply fractions? We multiply across, meaning 5 times 1 is 5. 5 times 4 is 20. 1 times 4 is 4. And 5 times 4 is 20. Now, whenever you add these fractions, we leave the denominator by itself. We add the numerator, so 5 plus 4 is 9. You have 9 over 20 equals 1 over t. Now, whenever you have two fractions equal to each other, or a fraction equal to a number, you can apply what we know as cross multiplication. Okay? And it's only when you have equality of fractions or equality of fractions and numbers. Okay? That's when you only apply cross multiplication. So what would cross multiplication look like? Well, in this case will be 9 times t and 20 times 1. Okay? So once you apply the cross multiplication, this is very important, you will not have a fraction anymore. So 9 times t will be 9t, and 20 times 1 will be just 20. Therefore, if I want to solve for t, I just divide 9 on both sides. So t equals 20 over 9. And that will be your solution. Okay? And that will be all for that problem. So let's check the other problems. Now this one, similar to the previous one, has fractions. Therefore, we need a common denominator. Now we can make our lives easier by just putting everything that does not have a fraction, like 1/3, into one side, and everything that does have a fraction to the other. So that's what I'm going to do. So 1/2 minus 1/3 equals 3 over x minus 2 over x. Now 1/2 minus 1/3, you need a common denominator. So we multiply 1/2 by 3 over 3. And then we multiply the 1/3 by 2 over 2. Now, here in the right side of the equality, we do have a common denominator already, which is x. So the only thing we need to do is subtract the numerators, and 3 minus 2 is 1. So again, across, 3 over 6 minus 2 over 6 equals 1 over x. Okay. 3 minus 2 is 1, so 1/6 equals 1 over x. Again, we have a fraction equal to another fraction. Remember that we have to exclude the values. I forgot to mention that. We have to exclude the values for which the denominator will give you 0. So in this case, x cannot be 0. Okay. We cross multiply. So 1 times x is x, and 1 times 6 is 6. So that's your solution. Now let's increase the complexity a little bit more. So now you have x plus 6 over x equals to 5. We still need a common denominator, and we still need to exclude the values in the denominator that will give you 0. In this case, x cannot be equal to 0. Now, what is the common denominator between x and 6 over x? Well, we can make x into a fraction. Let's do that. Let's put a 1 in the denominator. Now you can see that the common denominator between 1 and x is x itself. So I'm going to multiply x over 1 by x over x. So x over x times x over 1 plus 6 over x equals to 5. Now, just like always, how do we multiply fractions? We multiply across. X times x is x squared over x plus 6 over x equals to 5. Now, just because there's an x in the denominator does not mean that adding fractions is just the numerators. But you cannot add x squared with 6. What you can do is put them together in a simple fraction. So x squared plus 6 will stay x squared plus 6, but now we only have one denominator, which is x. And it's very important to do that step, because if you don't do that step, you won't notice what to do next. And remember what I said about a fraction equal to a number? Well, technically, we can make this number into a fraction by adding a 1 under it. So now we have a fraction equal to a fraction, and we can apply the cross multiplication. So x squared plus 6 times 1 is just x squared plus 6. X times 5 is just 5x. Now notice what we have now. We have a quadratic. And since we've been learning quadratics, you can notice that the first thing I want to do is subtract the 5x. So you're going to have x squared minus 5x plus 6 equal to 0. Now, remember, the 5x, I'm going to put it in the middle, because in order to use the x method or the quadratic equation, I need x in the middle. Now, clearly this is an x method problem. So on top you have a times c, on the bottom you have b. There's no number in front of x squared, is 1. And c is 6, so 1 times 6 is 6. b is negative 5. So 2 factors of 6, then when you add them gives you negative 5. Well, of course, negative 6 and positive 1. Now we continue. X squared minus 6x plus 1x, which is just x, equal to 0. We factor the first two, the last two. What can we factor between x squared and 6x? Well, x itself. You're left with x minus 6. Now, what can you factor between x plus 6? Oh, look. Negative 6 and 1 will add to negative 5, but will not multiply to positive 6. So, this is incorrect. Now, in the classroom, you guys would have been, no, Borne, that's wrong. But since this is not the classroom, I'll have to restart. So let me erase this one. Okay. Sorry about that. Okay. So again, we subtract the 5x plus 6 equal to 0. 2 factors of positive 6, then when you add them gives you negative 5, will be negative 2 and negative 3. So 2 squared minus 2x minus 3x plus 6 equal to 0. We still factor the first two, last two. We can factor the x, you're left with x minus 2. You can factor the negative 3, and you're left with x minus 2. Now we can factor x minus 2 on both, so we'll have x minus 2 times x minus 3 equal to 0. Now, the next step will be split into 2. So x minus 2 equals 0, and x minus 3 equals 0. So now we add 2 on both sides. You have x equal to 2 and x equals to 3. And that will be both your solutions. Now let's go to a little more challenging one. Let's change colors and everything. So now you have a fraction with the denominators that are linear functions, and then also quadratic. So the question is, what's the common denominator between all these fractions? Well, in the left side, it's pretty obvious that the common denominator will be y times y plus 3. Okay? And the rule of thumb is, if you don't know what the common denominator is, just multiply them, and that will be a common denominator. It's not the lowest one, but it's still a common denominator. So on the left side, I'm going to multiply by y over y times 6 over y plus 3. On the right side, I'm going to multiply by y plus 3 over y plus 3. And for now, I'm just going to leave the right side by itself. Now, before we continue, we need to exclude the values that are going to give you 0 in the denominator. Well, from y plus 3, y cannot be equal to negative 3. Because if I plug in negative 3, I get 0. From y cannot be equal to 0. And from y squared minus 9, y cannot be equal to plus or minus 3. So all those three values have to be excluded. Now we continue. So how do we multiply fractions? Across. So 6y, y times y plus 3. I'm going to leave it as y times y plus 3. And you'll see why. Plus 2 times y plus 3. Remember, when you have a sum and there's a multiplication outside, you still have to distribute. So this is going to be 2y plus 6 over y times y plus 3. And again, I'm going to leave the right side by itself. Okay. Now, again, when you have a fraction, you can write them down as a one fraction. So I'm going to add the numerators. 6y plus 2y is 8y plus 6 over y plus 3 equals. Now comes the right side. Y squared minus 9. Using either the x method or the difference of squares, you can figure out that y squared minus 9 is the same thing as y plus 3 times y minus 3. Okay? Now, why do I want that? Well, notice that y plus 3 is common on both. So if I multiply y plus 3 on both, on the numerator, right, then you can get rid of the y plus 3 on the denominator. And that's what I want to do. I'm multiplying one side by y plus 3 over 1. On the other side, I'm going to multiply by y plus 3 over 1. Now, using commutativity of a multiplication, right? This whole thing is just multiplications all around. The 1 times y plus 3, I can switch them around using commutativity and associativity to move the y plus 3 under the y plus 3. So on the left side, I have 8y. Let's just go straight with the y plus 3. Now I have y plus 3. Again, I'm going to shift the y plus 3 under it. And on the right fraction, you have 8y plus 6 over y. And the other side, I'm going to do exactly the same thing. I'm going to switch the y plus 3 under the other one. So on the fraction, you'll have 5y minus 3 over y minus 3. And then I'll have y plus 3 over y plus 3. Now, if you got a little confused or lost, please pause it, rewind it, watch it again, so you can have a clear sense of what's going on. Now, y plus 3 over y plus 3 is 1, so you have left with 8y plus 6 over y. And on the right side, you have 5y minus 3 over y minus 3. Now you have a fraction equal to a fraction. Now it's convenient to cross multiply. So it's going to be 8y plus 6 times y minus 3 equal to 5y minus 3 times y. On the left side, you have to FOIL. So first, 8y times y is 8y squared. Outer, so 8y times negative 3 is negative 24y. Inner, 6 times y is 6y. And last, 6 times negative 3 is negative 18. On the right side, you just have to distribute. So 5y times y is 5y squared. And y times negative 3 is negative 3y. Now you have this entire quadratic that you have to equal to 0. Let's do that. 8y squared minus 5y squared. Negative 24y plus 6y is negative 18y. If you add the 3y to the left side, you have plus 3y minus 18 equal to 0. Now, 8y squared minus 5y squared is 3y squared. Negative 18y plus 3 is negative 15y. And then minus 18 equal to 0. Now, curiously enough, we can factor a 3 on everything. And you have y squared minus 5y minus 6 equal to 0. We can divide the 3 on both sides. 3 over 3 is 1. So you have you're left with y squared minus 5y minus 6. And 0 divided by 3 is 0. Now we can apply the x method. So a times c and b. Again, a times c is negative 6. And b is negative 5. So two factors of negative 6, then when you add them gives you negative 5. In this case, it is negative 6 and positive 1. So you have y squared minus 6y plus 1y minus 6 equal to 0. We factor the first two and the last two. Y times y minus 6 plus 1 times y minus 6 equal to 0. And you have y minus 6 times y plus 1 equal to 0. We split it into 2, so y minus 6 equals 0, or y plus 1 equal to 0. We add 6 on both sides. We have y equals 6, or y equals negative 1. And those are your two solutions. Notice that those two numbers are not part of the list of undetermined values. I mean, undefined values. And that will be all for this chapter. If you have any questions, please leave it in the comments below or ask me in class. Thank you.